All right, welcome to the Explainer. Today, we're jumping right into one of maybe the most debated and confusing terms in all of tech, artificial general intelligence. AGI. It seems like it's everywhere, but what are we actually talking about when we say that?
I mean, that's the thing, right? Everyone's talking about it, but if you ask 10 experts what it is, you might get 10 different answers. Take Demis Hassabis, the CEO of DeepMind. For him, it's pretty straightforward. It's a system that can do pretty much any cognitive task a human can.
But that's just one take. You look at OpenAI, and they're coming at it from a totally different angle. They're focused on the economic side of things. For them, AGI isn't just about an AI being as good as us, it's about it being better than us at most of the jobs that, drive the economy.
And then you've got people like AI researcher Francois Chollet, who just pivot the entire conversation. He argues the real key isn't what an AI can do right now, but how fast and efficiently it can learn to do new things. The whole game becomes about adaptability, not just raw performance.
So you see the problem, right? With all these different definitions, the whole debate gets super polarized and, honestly, just confusing. How can we even track progress if we can't agree on what the finish line looks like? It's like everyone's running a different race. So, yeah, let's try and cut through the noise and get to the bottom of this.
Okay, so to really unpack this, we need to start by questioning the very foundation of almost every AGI definition out there, this core assumption that human intelligence is general to begin with. I mean, are we really?
Okay, take Magnus Carlsen. We all agree he's a chess genius, right? Maybe the best human player of all time. He's the absolute pinnacle of what a person can do in that game. But here's the kicker. Pit him against a modern chess computer, and it's not even a fair fight. From a purely computational point of view, he isn't actually that good at chess. The AI is just on another level.
And that gets to the crucial point here. We think of ourselves as general intelligences because we're judging from inside our own little bubble. We can't really see our own blind spots or just how specialized we are for the very specific survival tasks evolution shaped us for.
So if our basic premise, that humans are the yardstick for general intelligence, is shaky, then it's no surprise that our definitions for AGI start to fall apart. Let's actually look at a map of these definitions to see exactly where they go wrong.
This is a really fascinating way to visualize the chaos. What we've got here is a map of AGI definitions plotted on two axes. What the AI does, is it about learning or performing, and what's its scope? Can it do human tasks or literally anything? And you can see they clump into three totally different camps. You have the cognitive mirrors trying to copy us, the economic engines focused on work, and the adaptive generalists, all about learning. There's just no single coherent target.
Now, for any of these definitions to actually be useful, to be a real goal for the whole field, it can't just be a cool-sounding idea. It has to pass three basic tests. It needs to be consistent, it needs to be something we could actually feasibly build, and we have to be able to measure our progress toward it.
So let's put one to the test. Let's start with OpenAI's definition, which is firmly in that economic engine camp. It's all about outperforming humans at valuable jobs. On the surface, that sounds pretty practical, doesn't it?
Well, it turns out there's a huge problem. It completely fails one of our key criteria. You can't actually assess it.
Just think about it for a second. The list of economically valuable tasks isn't static. It's changing and growing all the time as technology evolves. So trying to build an AI to outperform us at this is like trying to hit a target that's not just moving, but also getting bigger and more complicated. It's an impossible benchmark.
Okay, so let's shift gears. What about those adaptive generalist definitions? The ones that say AGI should be able to do, well, literally anything. The dream of a truly universal, all-purpose intelligence. This one fails on a totally different and maybe even more fundamental level. It's just not theoretically possible. And this isn't just a hunch. There's actually a core concept in machine learning that proves it. It's called the no free lunch theorem. And what it boils down to is this. You can't have one master algorithm that's the best at solving every single problem. It just doesn't work that way. To get really good at something, you have to specialize. So this idea of a true universal intelligence, it's basically a mathematical impossibility.
And that leads us right to the big idea from the source material. Maybe we've been chasing the wrong thing. Instead of this impossible dream of a perfect generalist, the real path forward is to embrace the incredible power of specialization.
This diagram really drives the point home. You see the space of tasks humans can do and the space of tasks AIs can do. The overlap is interesting, sure, But the real goldmine? It's that huge area of AI-exclusive tasks. The true value of AI isn't just copying us. It's doing the things we're bad at or can't even begin to do.
So, with AGI being such a flawed and confusing term, the source paper we're looking at proposes a new North Star for the field, a better goal that actually leans into this power of specialization.
It's called Superhuman Adaptable Intelligence, or SAI. And listen closely to the wording, because the shift is crucial. It's not about doing everything from the get-go. It's about having the ability to adapt and learn to master any important task, whether it's something humans do or something totally alien to us. The focus flips from performance to adaptation.
And here's why this is so much more practical. It gives us a clear metric we can actually measure. It solves that assessment problem we talked about. The new yardstick is adaptation speed. How fast can an AI go from being a total novice to a superhuman expert at something? Now that's something you can track and improve.
Pursuing SAI also has another huge benefit. It forces us to move beyond the current monoculture of AI models. The big models we rely on today have some pretty serious flaws, like their errors can just snowball out of control. An SAI approach encourages us to build a whole zoo of different specialized solutions, because you're going to need different tools for different jobs.
So, what does this all mean for where AI is headed? Well, it completely reframes the entire goal. We're not trying to build one know-it-all. We're trying to build a team of world-class specialists.
I love how the authors of the source paper put it. We should be building insanely powerful, specialized AIs for the jobs that really matter. Trying to make a single do-it-all AI is just going to give you a system that's mediocre at everything and truly great at nothing.
And that really leaves us with a big question to think about. Maybe the whole idea of a single, godlike AGI was a red herring. By shifting our focus to superhuman adaptable intelligence, perhaps we can see that the future isn't one all-powerful mind, but an entire ecosystem of powerful, specialized tools, each one superhuman in its own unique way.